We're going to start by going over your homework. Like I said, these first 9 questions were all from page 4 of your notes. And these are just things that, these are the mineral questions that you just kind of got to know. They're not really in your reference table. They're just the facts that you have to know about minerals. So it starts off with this first one. This is the building. This is, what does it say? This is the atomic structure when oxygen and silicon bond together. Write from your notes, what is this shape? That, answer 1, that's a tetrahedron. Again, what do you need to know about the whole tetrahedron thing? All you have to know is that's when silicon and oxygen combine, they make this shape. So it ends up being kind of like a pyramid. It's like the 3 bigger guys on the bottom, and then the oxygen or the smaller one on top. The grouping of rocks as igneous, sedimentary, and metamorphic is based primarily on differences in origin, which, do you guys know what origin is? Where it came from or how it came, like where, it's basically its starting story, like where did it begin? So again, igneous are the ones that come from magma. Sedimentary are the ones that come from sediments, and then metamorphic are the ones that come from heat and pressure. So the first thing, when you get a pile of rocks, the first thing you're going to do is separate them based on how they're formed. What do most igneous, sedimentary, and metamorphic have in common? Not all, but most. Are they all produced by molten material? No, because that's only igneous. Are they produced by heat and pressure? All 3 of those? No, which one is that? But heat and pressure. Metamorphic. Are they mostly all composed of minerals? Sedimentary, metamorphic, and igneous? Yes, most rocks are made of minerals. No, not garnet. I know, I was being funny. Yes, you guys missed it. You must be tired too. Rocks are classified as igneous, metamorphic, and sedimentary based on their origin. Again, how they form. When various minerals are split by a wedge, some break evenly along flat surfaces while others fracture unevenly. Which property of a mineral is responsible for the way it splits? 3, the atomic arrangement of atoms. So how the atoms are put together controls everything. Which factor causes flat surfaces to be produced when some minerals are broken? 1, again, the arrangement of atoms. Of the Earth's more than 2,000 identified minerals, only a small number are commonly found in rocks. This fact indicates that most, did you guys actually try this one? I want you guys to read all 4 answers and see which one could be right based on the fact that only a small number of minerals are found in rocks. It is 3. Rocks have a number of minerals in common. Basically, all the rocks we're going to be dealing with this year, all are made of the same thing. It's just how they're put together that make them different. All right, so then you had some questions on 10. There were some parts of this that you may not have understood, but if you really stopped to think about what the question was saying, I bet you could have figured it out. This first one was a little tricky because you don't know what conglomerate is. You might not know what granite is, and you might not know what sandstone is. But when you read the question, a sample of conglomerate consists of mostly fragments of granite and sandstone. So let's take that part. Huh? Yeah, what did you say though? Okay, so what are fragments is actually the key there. They're like the things. What's a fragment of anything? A piece, a broken piece. So they're really broken pieces of granite and sandstone. Now, you might not know what granite and sandstone are, but you probably can guess they're other rocks, right? So broken pieces of other rocks. The best inference can be made from this sample is that conglomerate, does that description talk anything about fossils? No. Resulted from solidification. What kind of rocks come from solidification? Use your reference table. I heard somebody say it. Those are igneous rocks. No. So solidification is not broken pieces of rock, so that's not it. Is conglomerate formed from other rocks? Yeah, look, broken pieces of other rocks. Perfect. Metamorphic rocks could be the direct result of. Do metamorphic rocks directly result from melting and solidification? Nope, that's an igneous rock. Do metamorphic rocks, are they a direct result of weathering and erosion? No. What kind of rock would that be? That would be a sedimentary rock. Again, are they from the compaction and heating? Probably. Let's double check the last one. Erosion and deposition, is that metamorphic? No. No, this isn't the best words because compaction does go with sedimentary, but that's the only one it could be. Recrystallization of unmelted material under high temperature and pressure results in metamorphic. What were the keywords there? Temperature and pressure. Did you have any idea what recrystallization of unmelted material was? No, but as long as you know the high temperature and pressure, you could get that one right. Rocks are classified as igneous, sedimentary, or metamorphic based on 3, how they form. Which statement about the rock cycle is not true? Sedimentation leads to sedimentary rocks. That's wrong. Because we want the one that's not true. Sedimentation does lead to sedimentary rocks, so that's not it. When heat and pressure when heat is applied to a rock and it melts, that's the key word. No, if it melts, does it make a metamorphic rock? No, so that's the answer. That's the one that's not true. Burial process involving sedimentary rocks is usually, we did not cover this, but where do you think sediments, broken pieces of rocks are getting buried? Will they be deep inside the earth? No, that's not where rocks get broken. At the surface. An ocean ridge is way deep in the water. That's not going to be where they are. And finally, not quite finally, solidification of magma makes only igneous, not metamorphic. Which statement about metamorphic rocks is not supported by the rock cycle? So which again is wrong? A metamorphic rock may become sediments. Can that happen? No. Metamorphic rocks may become sediments. That one's correct. That one's good. Will metamorphic rocks may one day undergo melting? Yep, metamorphic rocks might melt. That one's true. A metamorphic rock has undergone sedimentation. No, that one doesn't have to be true. It could have at one point, but metamorphic rocks are not. That would be a sedimentary rock. Did you try? Yeah. Did you use your reference table? All right, so hopefully within it, so if you did have a rough time with that, my questions are the same. Did you use your reference table? Did you actually try? But if you did answer yes to those 2 questions, then the stuff we're going to do over the next few weeks, days, week and a half, week and a half or so, will help you get a little bit better because we're going to take each rock type and spend multiple days just learning about each type of rock. No, I mean, when you go to lab, you will. Oh, okay. All right. So we are going to start focusing on igneous rocks today. And so that you don't just have to listen to me talk or whine at this point, what we're doing is just a short reading. As you can see, it's not even a whole page. And then we're going to do this top compare and contrast chart. What? Are you just hitting your head? Okay. So in the reading, here's what we're going to be looking for in the reading. The environment of formation. What do you think I mean by environment of formation? Yeah, what's that mean? How, am I really looking for how it formed? So what do I mean by the environment? Okay, the rock's habitat, okay. Wow, it's like your teachers last year are coming back into your heads. They'll be proud of you. I'm really just asking where they formed. No, that's not good enough. So where they formed. How they formed. I'm looking for, since we're talking about igneous rocks, I want to know how they cooled. So in the reading, it'll tell you how they cooled. Physical properties. I'm looking for how these look. And the examples, there's a couple examples in each, for each one. So we're just going to do the top for right now. We'll see how far that gets us. But right now, and these are going to be your notes. So let's do this by going, you're going to be intrusive, first row. Second row, you're going to be extrusive, intrusive, extrusive, intrusive, extrusive. Okay? In X, in X, in X. Go find the, if you just want to go highlight it or underline it, go find the answers to your 4, what is that? 1, 2, 3, 4, 5 questions for your part only. Don't bother going to the other part in the reading right now. If you do want to, oh, you can't rip it out, but you can open it so you have both of them there. You don't have to do any writing right now. Just go find the answers. Either circle them, highlight them. If you want a highlighter, they're over there under the shower. So you're going to the reading again and looking for where they formed, how they formed, what they look like, and giving me some examples for each one. All right, so from the reading, let's start with the intrusive. All right, so we went every other here. Intrusive people. Where do the intrusive igneous rocks form? I'm sorry, what? No, again, it says where. Deep within Earth's crust. I don't even want to include the word crust though. So what we're going to have in the intrusive is deep inside the earth. If everybody needs to write that, then this is going to be our notes for intrusive and extrusive. Yes. So Logan, how did they cool?
They cool slowly in the Earth's crust.
Cool slowly.
It says underground.
Underground. You don't need, because again, we got the where up here. So I'm just asking how. They cooled slowly. Because they cool slowly, what does it say they look like? Large crystals. And what examples did they give you? Granite. Do you guys know granite? Nope, that's marble. Yeah, it's that nice stuff. Yeah. It's what your counter probably is. Granite countertops are the best example of this. You guys have all seen granite, I promise you. If nothing else, you've probably seen granite around here. We see it.
It seems like that's not.
Can it be black? It sure can. That's what the countertop would look like. You're right, it does look like it's gonna fall, doesn't it?
You're already having a bad day.
I am not going well today. So you can see here, this is a piece of granite that's kind of raw, I guess is what you'd call it on the outside. So you've probably seen rocks like this. They tend to not be the ones that the ground is made out of around here, but we will find pieces of granite just in streams and in the ground. But that's what they look like when they're cut and polished and made into countertops. And then you ask, can they come in different colors? They can. It all depends on how many of the different minerals, like which minerals ended up the most in this piece of granite. And we're going to talk about the different minerals that can be in granite. But it does come in many, many colors. That's why they make great countertops. You can get them to look just the way you want. So again, with this whole large crystal thing, all of these chunks are crystals. Basically, a large crystal is just one you can see without like guessing. All of these little shiny pieces are crystals, and you can see them without squinting, without getting a magnifying glass. Nice, easy to see crystals. How about the extrusive? Where did they form? On Earth's, oops, that should be a capital. Oh, well, that shouldn't be a capital. On Earth's surface. How did they form on the Earth's surface? Wait, what?
Rapidly cool.
Cools rapid. Cools rapidly, cools fast. And because they cool fast, what do they look like?
Very small.
Okay, and I don't think the reading included this,
Unformed.
but small or no crystals. So include the no. And what were the examples given in the reading for that one? Obsidian and pumice. Basalt is another example. Was that in the reading?
Yeah.
Yeah, so basalt was another one. Guess I should have grabbed those while I was over here. Oh, now I see why I didn't grab them. I don't have them. Let me give me a second while I grab the.
Like you go around searching for these,
What was that?
like how do you find them?
They're labeled and I know where I'm
No,
going.
I mean like how do you?
Oh, where do I get all these rocks? I get all these rocks from the rock catalog. No, not Amazon. There's an actual. No, I have done that twice in my life. Wasn't a huge fan. You get dirty. It's not my thing. This is a piece of obsidian. Some of you guys are probably familiar with this one a little bit. There are no crystals versus all the crystals that you could see in this one. No, we're apparently not going to focus. And no, these ones are too strong for me to break. There we go. So we got crystals on this one. You could, I don't even think these would break if you drop these ones on the ground. So I'm not going to, because this rock was gifted to me when I was student teaching. So no, I can't break that one.
You don't have.
Other earth science teachers. We're a little weird, not gonna lie. This one is probably not the best example to show up here. I can pass it around. But this one also has no crystals. Those little black specks you see are actually holes in this rock. This rock cooled so fast that when the lava was out in the air, basically it cooled around air bubbles. So it basically cooled the instant it shot out of the volcano, and it got air pockets stuck into it. So it cooled so fast, just like, you know, when pizza crust cooks around an air bubble, you get that fast. So that's basically what happened. The pizza crust
Dude, I love lemon.
I know, it's the best. When it solidifies around an air bubbles, because it cooked while the air bubble was still in it. Same thing here, it just cooled while the air bubble was still in it. I want to stop now. So you are going to have no homework. The other classes that are going to have to catch up because they never did page 9, so they'll do that during class. You guys got extra points for it though.
Let's go. Buffalo.